Let's take some problem based on the center of mass. First question is, three particles of masses 50 gram, 100 gram and 150 gram are placed at vertices of an equilateral triangle of side 1 meter as shown in the figure. The xy coordinates of the center of mass will be. The coordinate of the center of mass can be written as x center of mass. This is the x coordinate will be summation of mi xi, where I refers the ith particle and mi refers the mass of ith particle and xi represents the position of the ith particle from the origin or the reference point, divided by summation mi. Similarly, y coordinate of center of mass will be summation mi yi divided by summation mi. The system has three particles, one is m1, another is m2 and third one is m3. So we can find the coordinate of center of mass as m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. And in short, we can write it as summation mi xi, where I equal to 1 to 3 divided by summation mi, where I equal to 1 to 3. Now we substitute the value. First particle is of mass 50 grams, so it is 50 into, it is at origin, so distance from origin will be 0. Another is 100 gram and distance is 1 meter, plus third one is 150 gram and its distance is 0.5 meter, divided by 50 plus 100 plus 150. So it will give 0 plus 100 plus 75 divided by 300, or 175 by 300. On dividing numerator and denominator by 25, we will have 7 and 12. So x coordinate has the value 7 by 12 from the origin. Similarly, y coordinate will be m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. Substituting the value, m1 is 50 gram. It is at origin, so y coordinate is also 0, plus 100 gram into y coordinate of the second mass is also 0, and third one is 150 gram. And to find the y coordinate, we have to use Pythagoras theorem, in which in a right angle triangle having the length 1 meter and this length is 0.5 meter, so this hypotenuse or perpendicular will be of value square root of 1 square minus 0.5 square, that is equal to 0.75, or we can write it as 0.5 root 3. So we have to substitute the value here, 0.5 root 3 divided by 50 plus 100 plus 150. So this first term is 0, second term is 0, therefore we will have 75 root 3 by 300, dividing by 25, it will be 3, and here it is 12. It is equal to 3 root 3 by 12. Further, on dividing by 3, it is 4. So it is 3 by 4. So center of mass have the coordinate xcm, ycm equal to 7 by 12 and root 3 by 4. Hence option C is the correct option. Second question is, the position vector of the center of mass RCM of an asymmetric uniform bar of negligible area of cross section as shown in the figure is. The figure shows a asymmetric bar which is uniform. One part is having the mass 2m, second part is having the mass m, and third part is having the mass small m. Their centers are suppose A, B, and C. These are the center of mass of these individual parts. Their position with respect to reference O is, suppose this is RA, another is having the position vector RB, and third one is having the position vector RC. So we can write RA equal to, if we see the projection of the position vector RA along the x-axis is L, so we can write it as Li. I is the unit vector along the x-axis, suppose this is the x-axis and vertical axis is y-axis, plus, and along the y-axis the projection is of length y, L, so it is Lj. Similarly, we can write for RB, which is the position vector of the point B with respect to origin. It is having the length 2L, So it is 2Li along x-axis plus, and along the j-axis this length is L by 2, so it is L by 2 j. And third point, which is RC, having the position vector, is equal to the midpoint have the distance from the origin of 2.5L, or we can write it is 5L by 2. So it is 5L by 2I, and in vertical direction it is 0 plus 0j. Now we have to find the center of mass. So position vector of center of mass will be equal to summation of mi into ri divided by summation mi, and substituting the value we will have m1, which is having the mass 2m. Its position vector is li plus lj. Then another mass is of m, so plus m. Its position vector is 2li plus L by 2j. And third is also have the mass m, and position vector is 5L by 2I. Because this 0j will be equal to 0, so it is equal to 5L by 2I. Divided by sum of the masses, this is 2m plus m plus m. Now on taking the common m and l from the numerator, we will have m into l. Remaining will be 2i plus 2j, then plus 2i plus 1 by 2j, and then 5 by 2i. And denominator have the value 4m. M and m get cancelled, so it will be equal to L by 4 into, we will add I term, so this is 2 or 2, 4, and then plus 5 by 2, so it will be 13 by 2i, and j is will have the value plus 5 by 2j. Therefore, it will have the value 13 by 8 Li plus, this is 5 by 8 Lj. Hence, option A is the correct option. Here, I refers the unit vector along the x-axis, which in the question is marked with x bar or x caret, and j refers the unit vector along the y-axis, which is represented here y caret. So we can also write it as 13 by 8 L x plus 5 by 8 L y. Third question is, distance of the center of mass of the solid uniform cone from its vertex is z0. If the radius of its base is capital R and its height is h, then z0 is equal to. First we will draw the figure for the cone. The cone is having the vertex at the origin of our reference coordinate system. This is x-axis and y-axis, and O is the origin, and the vertex of the cone is at the origin. The height of the cone is h from the origin or the vertex of the cone, and radius of the cone is given capital R. Suppose we take a arbitrary point at a height z from the origin, and it has a circular cross section of the radius say r. We take a thickness or elementary thickness of dz, and for this portion we will find the volume and then mass of this cross section having the thickness dz. For this, the area will be equal to pi r square for the circular cross section having the radius small r, and the volume will be equal to pi r square into dz. By the property of the cone, we know that the ratio of the capital R by small r will be equal to h by z. So we can write that R equal to capital R into z by small h, and we will use this formula to solve the problem. So center of mass ZCM, which is given Z0, will be equal to integral Z dm, because mass distribution is continuous, so we will use integral method, divided by integral dm. For cone, this integral dm refers the mass of the cone, so it will be equal to, mass is the density into volume. Volume is 1 by 3 pi r square h for the cone, and in numerator we will have z into rho into, and volume of the elementary portion is the pi r square into dz. Here z will be from 0 to capital H. So it will be equal to, this rho is constant, so it will be cancelled. Similarly, pi will get also cancelled, and we will have z is equal to 0 to h, z into r square dz divided by 1 by 3 r square h. It will be equal to integral z equal to 0 to h z into, and now we will substitute the value of r from the formula r equal to capital R z by h. So it will be r square z square by h square into dz divided by 1 by 3 r square h. It will be equal to, this 3 will come in numerator, so it is 3 into 3 by r square into h into, and on right hand side in the integral, this r square is constant and h square is also constant. So we will take it out of the integral. It is r square by h square, and remaining is z is equal to 0 to h z cube dz. So it is, this r square get cancelled. This is r3 by h cube, and integral of z cube is z raised to the power 4 by 4, and limits are z is equal to 0 to h. So we will now put the limits. It will be h raised to the power 4 by 4 minus 0. So it is equal to 3 by 4 into h raised to the power 4 by h raised to the power cube, and it is equal to 3h by 4. Hence option A is the correct option. Fourth question is, a uniform rectangular thin sheet ABCD of mass m has length A and breadth B as shown in the figure. If the shaded portion HBGO is cut off, the coordinate of the center of mass of the remaining portion will be. The center of mass have the x coordinate for the remaining portion is equal to m1 x1 minus m2 x2. Here we will use minus when we use the cutoff portion, divided by m1 minus m2, where 1 refers the whole body and 2 refers the cutoff portion. So on substituting the value, the mass of the whole body is given capital M, and its position of the center of mass from the reference point 0 0 is a by 2 in x direction, minus mass of the cutoff portion will be m by 4, that is a 1/4 of the total rectangular sheet, because sheet is uniform, so it is m by 4, and its position from the reference point D will be the a by 2 and then a by 4. So it is 3a by 4 divided by m minus m by 4. So on solving, it will be ma by 2 minus 3ma by 16 divided by 3m by 4. Here m get cancelled because this is common in numerator and denominator. So we will have a by 2 minus 3a by 16 divided by 3 by 4. It will be equal to, in numerator it will be 16 and then 8a minus 3a divided by 3 by 4. So it will be equal to 5a by 16 into 4 by 3. On cancelling, we will have 5a by 12. And symmetrically, we can find that YCM will also of the same form by changing the A with B. So we will have YCM will be 5B by 12. Hence coordinate will be XCM and YCM for the remaining portion is equal to 5A by 12 and 5B by 12 with respect to the reference point D. Hence option B is the correct option. Fifth question is, a circular plate of uniform thickness has a diameter of 56 cm. A circular portion of the diameter 42 cm is removed from one edge of that plate as shown in the figure. Find the position of the center of mass of the remaining portion. For a portion cut from the body, the center of mass of the remaining body will be equal to m1 x1 minus m2 x2 by m1 minus m2. Here 1 refers the whole body and 2 refers the cutoff portion. In the shown diagram, if we take the reference point O, which is having the coordinate 0, 0. Then left side we will consider it as a positive direction, and the whole body has a center at A, which is at a distance, say, half of the diameter, which is 28 centimeter from the reference point. And the center of the cutoff portion is, say, B, and it has the distance from the reference point as half of the diameter, so it is 21 centimeter. So we can substitute the value for masses. M1 is the mass of the whole body, so it is having the density into volume. So density will be rho, which is same for the whole body or cutoff portion or remaining portion, while the volume of the whole body will be area of the plate into thickness of the plate. So it will be equal to rho into area of the plate depends on the radius, so it is pi into r square into t. So we will use the formula. It is equal to mass of the whole body will be density into pi into radius is 28. So 28 square into thickness is t minus mass of the, and then multiply with distance x1 from the reference point. So it is 28. Then minus mass of the cutoff portion, it will be rho density, then pi, and its radius is 21 square into thickness is t, and distance of the point B, that is the center from the reference point, is 21, and divided by rho into pi into 28 square into t minus rho into pi into 21 square into t. So it will be equal to, here we can take rho, pi and t common. So remaining is 28 cube minus 21 cube divided by rho, pi, t and 28 square minus 21 square. This rho, pi, t get cancelled. So it is equal to 28 cube minus 21 cube divided by 28 square minus 21 square. We can factorize them. So it is 28 minus 21 into 28 square plus 21 square plus 28 into 21, and divided by 28 minus 21 into 28 plus 21. These get cancelled. So it is equal to 28 square plus 21 square plus 28 into 21 by 28 plus 21. On solving, it is 37 centimeter. So center of mass of the remaining portion will be at a distance 37 centimeter from the reference point O, and in respect of point A. From point A, the distance of the center of mass will be, because distance of point A from the origin is 28 centimeter, so this will be equal to 37 minus 28, and that will be equal to 9 centimeter. This is the answer. And this point will be point C, which is at a distance 37 centimeter from the reference point O. Sixth question is, two particles A and B initially at rest moves towards each other by the mutual force of attraction. At the instant when the speed of the A is v and the speed of B is 2v, the speed of the center of mass of the system is. The speed of the center of mass is given by mass of body A into velocity of body A plus mass of velocity B into velocity of body B divided by mass of body A and mass of body B. Initially, the velocity of center of mass will be 0 because VA is 0 and VB is also 0. And as per question, the masses are moving towards each other by the mutual force of attraction, which is an internal force. This means external force, which is equal to rate of change of momentum, is equal to 0, or momentum will be a constant term. Momentum is the mass into velocity, so it is constant, or we can say velocity of center of mass is constant. It means initial velocity of center of mass will be equal to the final velocity of center of mass. We have calculated that initial velocity is 0, so finally also the center of mass will be at rest. Hence option D is the correct option. Seventh question is two blocks of masses 10 kg and 4 kg are connected by a spring of negligible mass and placed on a frictionless horizontal surface. An impulse gives the velocity of 14 meter per second to the heavier block in the direction of the lighter block. The speed of the center of mass is. So in the question, say heavier block is A, so mass of the block A is 10 kg and lighter block has the mass 4 kg. Because the spring is massless, so it have no contribution towards the velocity of center of mass. Therefore, velocity of center of mass will be equal to mass of A into velocity of A plus mass of B into velocity of B divided by the mass of A and mass of B. This will be equal to 10 into velocity of the body is 14 meter per second, so it is 14 plus block B have the mass 4 and it is initially at rest divided by what 10 plus 4. So it will be equal to 140 by 14 and it is equal to 10 meter per second. Hence option C is the correct option. Eighth question is four particles A, B, C, D with masses Ma equal to m, mb equal to 2m, mc equal to 3m and md equal to 4m are at corners of a square. They have acceleration of equal magnitude and direction as shown. The acceleration of the center of mass of the particle in meter per second square is. For the acceleration of center of mass, formula is summation of mi ai by summation of mi. There are four masses at the point A, B, C and D. If we write the acceleration in terms of the directions, we will have that acceleration of A will be equal to minus AI because it is in minus x direction. Similarly, acceleration of B will be equal to A into J because it is in plus y direction. Acceleration of C will be equal to A into I and acceleration of D is will be equal to A into minus J, that is equal to minus AJ. So we can write that it is first is mass of A is given m into acceleration is minus AI plus mass of B is 2m and acceleration is AJ plus 3m acceleration is AI and then 4m and acceleration is minus AJ divided by sum of masses, that is m plus 2m plus 3m plus 4m. So it will be equal to minus MAI plus 2MAJ then plus 3MAI and then minus 4MAJ divided by, and total sum of the masses will be 10m. It will be equal to, here m and a are common, so we take it common, remaining is minus I plus 2j then plus 3I and minus 4j by 10m. M and m get cancelled, so it is equal to a by 10 into, and here it is 2I then minus 2j. 2 is taken common and by cancelling we will have a by 5 I minus j. Hence option A is the correct option.